Machine learning questions that interviewers really care about. What are content-based filtering and collaborative filtering, and how do they differ? Answer. Content-based filtering is a method of recommending items to a user based on their past behavior, preferences, and interests. For example, if a user has shown interest in action movies, content-based filtering will recommend more action movies to that user. On the other hand, collaborative filtering recommends items to a user based on the preferences of other users who have similar tastes. For instance, if a user has watched several action movies, collaborative filtering will recommend other action movies that were also watched by users who have similar movie preferences. The key difference between the two is that content-based filtering focuses on the user's individual preferences, while collaborative filtering considers the preferences of a broader group of users. What is deductive learning and inductive learning? How do they differ? Answer. Deductive learning is a top-down approach where a general principle or theory is used to make specific predictions about observations or new data. On the other hand, inductive learning is a bottom-up approach where specific observations or data are used to form a general principle or theory. While deductive learning starts with a hypothesis and tests it through observation and experimentation, inductive learning starts with observations and forms a hypothesis. We use deductive learning when there is a theory available, and inductive learning when there is little or no data available to derive conclusions. How would you differentiate data mining from machine learning? Answer. Data mining is the process of extracting valuable patterns and insights from large datasets using various techniques, whereas machine learning is the development of algorithms that enable machines to learn from data without being explicitly programmed. In other words, data mining is the application of machine learning algorithms to discover hidden patterns and relationships in data. While data mining focuses on extracting insights from existing data, machine learning focuses on developing intelligent systems that can learn and improve over time. Why is the ROC curve important? Answer. The ROC curve is important because it is a visual representation of how well a model can distinguish between two classes, and it can be used to compare different models. The area under the curve AUC is a measure of how well the model performs, with a higher AUC indicating a better model. Additionally, the shape of the curve can indicate whether a model is biased towards one class or another. Why does overfitting occur in ML? Answer. Overfitting occurs in machine learning when the model is too complex or has too many parameters relative to the amount of data that is available. This causes the model to fit the noise of the data rather than the underlying patterns, resulting in poor generalization and an inability to accurately predict on previously unseen data. In other words, the model becomes too specialized to the training data and fails to generalize well to new unseen data. This is because the model has too many degrees of freedom, allowing it to fit the random fluctuations in the training data rather than the underlying relationships. As a result, the model performs well on the training data but poorly on new data, which is a hallmark of overfitting. What are the functions of unsupervised learning? Answer. Unsupervised learning is a type of machine learning where the algorithm identifies patterns and relationships in the data without being guided by a specific target output. The main functions of unsupervised learning are dimensionality reduction, finding clusters of data, and anomaly detection. Dimensionality reduction helps to reduce the number of features in the data, making it easier to visualize and analyze. Finding clusters of data helps to identify groups of similar data points, which can be useful for identifying customer segments or detecting anomalies in a dataset. Anomaly detection helps to identify data points that do not fit the typical pattern, which can be useful for identifying unusual or suspicious behavior. What are some functions of supervised learning? Answer. Supervised learning is a type of machine learning where the algorithm is trained on labeled data to predict the output for new, unseen data. Some common functions of supervised learning include regression, where the algorithm predicts a continuous value, feature selection, where the algorithm identifies the most important features in the data, classification, where the algorithm categorizes data into predefined classes, and time series forecasting, where the algorithm predicts future values in a time series based on past values. These functions enable supervised learning to be used in a wide range of applications, such as image recognition, natural language processing, and predictive maintenance. What are the two components of Bayesian logic? Answer. Bayesian logic consists of two main components, the prior distribution and the likelihood principle. The prior distribution represents the information or beliefs we have about the world before observing any new data. It's like our initial guess or hypothesis. The likelihood principle, on the other hand, describes the probability of observing some data given a particular state of the world. It's like a mathematical formula that helps us update our prior knowledge based on new evidence. Together, these two components allow us to make informed decisions and predictions by combining our prior knowledge with new data. How would you describe a recommender system? Answer: a recommender system is a system that predicts users' likes and interests and recommends products that fit their tastes. It uses data from various sources, such as user ratings of movies and songs, search engine history, and other online activities to make personalized recommendations to users. This system helps users discover new products, services, or content that they might enjoy, making it a powerful tool in the world of e-commerce, entertainment, and more. What functions are used to perform categorical conversion into factor? Answer: the functions used to perform categorical conversion into factor are factor and is factor. These functions convert categorical values into factors, which are numeric inputs that ML algorithms require. This conversion allows ML models to process categorical data. Are elements stored consecutively in linked lists? Answer: no, elements in linked lists are not stored consecutively. Each node in the list contains a reference link to the next node, which means elements can be stored anywhere in the list, not necessarily in a continuous sequence. What is regularization in machine learning? Answer: regularization is a technique used in machine learning to prevent overfitting in models. Overfitting occurs when a model is too complex and fits the training data too closely, resulting in poor performance on new, unseen data. Regularization adds a penalty term to the model's objective function, which encourages the model to find simpler solutions by reducing the magnitude of the coefficients or parameters in the model. This helps the model generalize better on new data by reducing its ability to fit the noise in the training data. Regularization techniques such as lone lasso and L4 ridge regularization are used to achieve this. Do you consider decision trees to have any advantages or disadvantages? If yes, what are they? Answer: decision trees have several advantages, including their interpretability, scalability, and accuracy. They are great for classifying data points quickly and accurately, and are well suited for dealing with large datasets. Additionally, they are simple to understand, making them a great tool for explaining complex models to non-technical stakeholders. However, decision trees can also have some disadvantages, such as being prone to overfitting and requiring careful tuning of hyperparameters to achieve optimal performance. Despite these limitations, decision trees remain a popular and effective machine learning algorithm. What do you understand about the exploding gradient technique problem in the backpropagation technique? Answer: the exploding gradient problem occurs when large error gradients gather in training, resulting in large changes in the neural network weights. This can cause the values of the weights to become too large, leading to not a number of values, which can prevent the training process from continuing. This problem is often seen in deep neural networks where the gradients are multiplied many times, causing them to grow exponentially. The exploding gradient problem can be addressed by using techniques such as gradient clipping, gradient normalization, or using optimizers that are more robust to large gradients. What do you understand about the bias-variance trade-off? Answer: the bias-variance trade-off is a concept that a model's ability to generalize to new data is limited by the trade-off between its simplicity low variance and its ability to fit the training data low bias. A simple model with few parameters will have high bias and low variance, meaning it will struggle to fit the training data but will generalize well to new data. On the other hand, a complex model with many parameters will have low bias and high variance, meaning it will fit the training data well but will overfit and struggle to generalize to new data. The goal is to find the right balance between these two extremes to achieve good generalization performance. How would you describe inference score and how would you use it? Answer: inference score is a measure of a model's predictive performance in binary classification, combining precision and recall. It's a weighted average of these two scores, providing a balanced view of a model's accuracy. The phone score ranges from 0 to 1, with 1 being the best and 0 being the worst. This score is used in information retrieval to evaluate a model's ability to recover relevant results and its overall performance. Explain the difference between the loss functions and cost functions. Answer: the loss function refers to the calculation of loss considering only a single point, whereas the cost function refers to the calculation of the sum of errors for multiple data. In simpler terms, The cost function sums the difference for the training database, while the loss function shows the difference between the actual and predicted values for a single record. How do you handle outlier values in data analysis? Answer outliers can be handled in 3 simple ways: dropping them, marking them as outliers and including them as a feature, or transforming the feature to reduce their effect. Dropping outliers can be useful if they are errors or unusual data points, but it can also lead to a loss of valuable information. Marking outliers as a feature can be useful if they are meaningful and provide additional insights. Transforming the feature can be useful if the outlier is due to a nonlinear relationship or a non-normal distribution. Each method has its own advantages and disadvantages, and the choice of method depends on the specific problem and data. What is a random forest and how does it work? Answer: a random forest is a machine learning method that combines multiple decision trees to make predictions. Each decision tree is built using a different subset of the training data and a random subset of the features. This randomness helps to prevent overfitting and improve the generalization of the model. The random forest works by predicting the output for a new input by aggregating the predictions from each decision tree. The final prediction is usually the mode or the average of the predictions from all the trees. This approach helps to reduce the bias and variance of the model, making it more robust and accurate. How do we select a sample size from the training data? Answer: to select a sample size from the training data, we can randomly take a subset of the data to use for training our model. This is a common technique in machine learning, as it allows us to reduce the computational resources required for training while still maintaining a representative sample of the data. By taking a random sample, we can ensure that our model is trained on a diverse set of examples, which can help to improve its performance on unseen data. The sample size can be determined based on the specific requirements of the project, such as the amount of data available, the complexity of the model, and the desired level of accuracy. How do I start with a particular node in a graph? Answer: to start with a particular node in a graph, you can simply choose that node as the starting point. This means you will begin your traversal or search from that specific node. For example, if you have a graph with multiple nodes, you can decide which node you want to start with and then move to its neighbouring nodes. This approach is commonly used in graph algorithms such as graph traversal or graph search. By starting with a particular node, you can explore the graph and find the desired information or solution. What is the first step in building a decision tree using the CART algorithm? Answer: the first step in building a decision tree using the CART algorithm is to run the algorithm from the start node. This involves checking if the number of observations is smaller than the node size. If it is, the algorithm stops. If not, it proceeds to select random variables, identify the best feature to split the observations, divide the observations into 2 nodes, and recursively call step on each of these 2 nodes. This process continues until the stopping criterion is met. What ensemble techniques can be used to aggregate multiple models? Answer: 2 common ensemble techniques used to aggregate multiple models are bagging and boosting. Bagging, also known as bootstrap aggregating, involves training multiple independent models on different subsets of the training data and then averaging their predictions to form the final prediction. This technique helps reduce the variance of the model. Boosting, on the other hand, is an iterative technique where models are trained sequentially, with each subsequent model focusing on the instances where the previous model performed poorly. This helps reduce the bias of the model. Both techniques are used to improve the accuracy and robustness of machine learning models by combining the strengths of multiple models. What methods can be used to find the threshold of a classifier? Answer: the threshold for a classifier can be found using 2 methods: precision recall curves and ROC curves. These methods help in identifying the optimal threshold value by analysing the trade-off between precision and recall of true positive rate and false positive rate. Additionally, a grid search can be employed to adjust the threshold and find the best value for the classifier. This involves varying the threshold and evaluating the performance of the classifier at each iteration, allowing for the selection of the optimal threshold value. How can you check for the normality of a dataset? Answer: to check for the normality of a dataset, you can use various plots and statistical tests. Some common methods include the Kolmogorov-Smirnov test, Shapiro-Wilk test, Anderson-Darling test, and D'Agostino-Skenes test. These tests and plots help identify if the data follows a normal distribution or not. For instance, if the data is normally distributed, The plot should resemble a bell-shaped curve, and the test should indicate a high probability of normality. If the data is not normally distributed, these tests and plots can help identify the type of distribution it follows, such as skewed or bimodal. By using these methods, you can determine the normality of a dataset and make informed decisions about data analysis and modeling. How can you differentiate between a parametric and a non-parametric model? Answer: parametric models have limited parameters and only need to know the model's parameters to predict new data. On the other hand, non-parametric models have unlimited parameters and have more flexibility in new data prediction. This means that parametric models are more restrictive and rely on a specific set of assumptions, whereas non-parametric models are more flexible and can adapt to new data without making assumptions about the underlying distribution. Do you think logistic regression can be used for more than two classes? Answer: no. Logistic regression is a binary classifier, which means it can only be used to predict the probability of an outcome being one of two classes. However, there is a variation of logistic regression called multinomial logistic regression that can be used to solve multi-class classification problems, where the outcome can be one of more than two classes. What differences exist between softmax and sigmoid functions? Answer: the sigmoid function is used for binary classification, mapping any input value to a value between 0 and 1. In contrast, the softmax function is used for multi-classification, where the sum of the probabilities will be 1. This means that sigmoid is used when there are only two classes, while softmax is used when there are more than two classes. Additionally, sigmoid is used as an activation function in the output layer of a neural network, while softmax is used as an activation function in the output layer of a neural network for multi-class classification problems. How can overfitting be avoided in machine learning? Answer: overfitting can be avoided in machine learning by using various techniques. One common method is cross-validation, which involves splitting the dataset into training and testing sets to evaluate the model's performance. Another approach is custom feature selection, where irrelevant or redundant features are removed to reduce the complexity of the model. Data augmentation can also be used to artificially increase the size of the dataset, making it more robust to overfitting. Additionally, using larger datasets can help to reduce overfitting by providing more examples for the model to learn from. Data simplification, ensembling, and regularization are other methods that can be employed to avoid overfitting. By using these techniques, machine learning models can be trained to generalize well to new and seen data and avoid overfitting. Which is more dangerous, a false positive or a false negative? Answer: a false negative is risky in situations where a mistake can have severe consequences, such as in medicine when a virus is not detected. On the other hand, a false positive is risky in situations where it can cause an SS reaction, such as in spam email detection when an important email is mistakenly classified as spam. The choice between the two depends on the specific context and the potential consequences of each mistake. How would you handle a dataset suffering from high variance? Answer: to handle a dataset suffering from high variance, you can use the bagging algorithm, which involves splitting the data into subgroups by sampling with replacement from the original data. Then, a training algorithm is used to establish rules for each subgroup. Finally, the predictions from each subgroup are combined using a polling technique, which helps to reduce the effect of high variance in the dataset. This approach can improve the overall performance of the model by reducing the impact of noisy or outlier data. Explain genetic programming as it relates to evolutionary algorithm. Answer: genetic programming is a type of evolutionary algorithm that uses the principles of natural selection and genetics to evolve computer programs that solve a specific problem. It starts with a random population of programs, and through generations of evaluation and modification, the fittest programs are selected and modified to create new programs. This process continues until a satisfactory solution is found. Genetic programming is similar to evolutionary algorithm, but it focuses on evolving programs rather than searching for optimal solutions. It is widely used in fields such as artificial intelligence, machine learning, and optimization problems. What are some classification methods that SVM can handle? Answer: SVM support vector machine can handle various classification methods including binary classification, multiclass classification, and multilabel classification. Binary classification involves distinguishing between two classes, while multiclass classification involves distinguishing between more than two classes. Multi-label classification is a type of multi-class classification where an instance can belong to multiple classes simultaneously. SVM is effective in handling these classification methods due to its ability to find the optimal hyperplane that separates the classes. Why do you think instance-based learning algorithm is sometimes referred to as a lazy learning algorithm? Answer: instance-based learning algorithm is sometimes referred to as lazy learning algorithm because it does not require any training data or generalization of the data. Instead, it uses the data the algorithm is given and stores it in memory for use in future predictions. The algorithm does not actively learn from the data, but rather relies on the stored instances to make predictions. Thus, its learning process can be seen as lazy as compared to other algorithms that actively learn from the data. Explain the reason for pruning of a decision tree. Answer: pruning is done to prevent overfitting by removing unnecessary nodes in a decision tree, which reduces its complexity and improves the generalization accuracy of the model. This helps in avoiding the model from becoming too specialized to the training data and instead makes it more accurate in making predictions on new and same data. How does regularization reduce the cost term in a model? Answer: regularization reduces the cost term by adding a penalty term to the cost function, which discourages the model from assigning too much importance to any single feature or parameter. This penalty term is designed to encourage the model to distribute importance across all features, preventing overfitting. As a result, the model is forced to find a balance between fitting the training data and avoiding overfitting, leading to a more generalizable and robust model. What's the need to convert categorical variables into factors? Answer: converting categorical variables into factors is necessary because many machine learning algorithms cannot work with categorical variables in their raw form. Machine learning algorithms work with numerical values, and factors are a way of representing categorical variables as numerical values. This allows the algorithms to process and analyze the categorical data in a way that is meaningful and useful for making predictions and drawing conclusions. Do you believe treating a categorical variable as a continuous variable will result in a better predictive model? Answer: treating a categorical variable as a continuous variable is not always the best approach for building a better predictive model. This is because categorical variables are inherently non-ordinal, meaning their values do not have a natural order or ranking. In contrast, continuous variables have a natural order and can be used in mathematical operations like addition and multiplication. If a categorical variable is treated as continuous, it can lead to incorrect assumptions and poor model performance. Instead, it's often better to use techniques like one-hot encoding or label encoding to convert categorical variables into a format that can be used in machine learning models. This approach ensures that the categorical variable is represented accurately and can lead to better predictive performance. Why do we need the confusion matrix? Answer: the confusion matrix is used to summarize predictions on a classification model, enabling us to visualize the performance of an algorithm or model. It measures the performance of an algorithm or model by providing a summary of true positives, true negatives, and false negatives, which helps us understand the accuracy and effectiveness of the model. This information is crucial in evaluating the model's performance and identifying areas for improvement. What differentiates gradient boosting and random forest? Answer: gradient boosting and random forest are both ensemble learning algorithms used for classification and regression tasks. However, the key difference lies in their approach to combining individual models. Gradient boosting combines multiple weak models by iteratively adding them to the prediction, whereas random forest combines multiple decision trees by randomly sampling the data and features. This difference in approach leads to distinct strengths and weaknesses in their performance. Gradient boosting is particularly effective in handling complex interactions between features, while random forest excels in handling high-dimensional data and is more robust to overfitting. How does a Box-Cox transformation occur? Answer: a Box-Cox transformation occurs when a power transformation is applied to non-normal dependent variables to transform them into normal variables. This process involves the lambda parameter, which, when set to 0, indicates that the transformation is equivalent to a log transform. What functions can be used to identify, drop, and replace missing or corrupted values in a dataset? Answer: these null, dropner, and filler functions in pandas can be used to identify, drop, and replace missing or corrupted values in a dataset. The isNull function identifies missing values, the dropNull function drops missing values, and the fillNull function replaces missing values with a specified value. These functions are useful for handling missing data and ensuring data integrity in a dataset. How is data divided in cross-validation? Answer: in cross-validation, data is divided into 3 parts: training, testing, and validation data. Then, the data is further divided into k subparts, and the model is trained on k-1 of those subparts and tested on the remaining fold. This process is repeated k times, with each of the k folds used exactly once for testing. The final performance metric is the average of the performance metrics from each of the k test sets.